For our last STEM assignment, we were tasked with creating a paper circuit and a lesson plan to go along with this. I decided my students were going to create an interior wall design using different polygonal elements that we would have learned in our geometry unit that happens during the end of the year. My first step is to ask some questions, and these were the questions that I automatically thought of. One, how can I make this applicable to my students' lives? Then I asked myself, how can I incorporate math into this? Because I mainly teach math, I don't teach any science, so this would have to work with what I typically do. And then I thought, what if we created an interior wall design? Because that's what I think of when I think of an electrical circuit. Next, I had to do some research because I didn't know much about interior of walls other than what I'd seen on HGTV. And I found out that they include so many different pieces that my students could learn about and use. So here you see that picture of that wall, and so it really shows me, we'll teach my students the purpose of these different geometry terms like parallel and perpendicular and why they're important to our lives. And so those were the terms that I first thought were going to be in this project. So parallel, perpendicular, rectangles, and trapezoids were what I decided to go with for this project. Then I needed to plan. So in my plan, I decided to sketch out my design first and then trace it with marker. When I was designing with these different attributes, I decided to combine as many together to create as much space as possible, because one of the challenges was that my circuit couldn't touch anything else except for the beams. So I put my windows together and I tried to get my pipes to be perpendicular in two different spots to meet that assignment or challenge. Then I decided to where to put my lights and made little dots to draw it out, and then I did a rough draft of my circuit, and then I put the copper down. Now the kit said to cut the copper in half and use it that way, and then I put the lights on. Now this was really a challenge. I had to keep moving the lights around because they didn't work in all the places, and I kept moving the battery around to try and make it work. But in the end, I did get it to work. Thinking about my students, I don't think they'll think about it the same way I thought about it, putting those attributes together and creating as much space as possible, and so it'll be really interesting to see what they come up with. Improving. I'd want to include more wall designs and attributes because I think my students can handle it, and I think it will give a real picture of, again, what these geometry terms mean in real life. I also want to challenge students to use a light switch and keep the thickness of the copper wire the same as what it came in. Cutting it was just too thin and it made it really hard to work with. Also measuring out a path for the copper, that also was difficult. I didn't measure my path, I just cut and then tried to put it down, and I ran out. And so I really wanted to focus on, does this lesson present a real problem, an engineering challenge, and I don't think it did. I think this is an engineering challenge, but I don't think it's a real problem that people face. And so moving forward, I'm just going to try and think about how I can make this a real problem for my students.